This lesson is for students who went through the previous COVID time series. We're going to look at making some adjustments to that. So if you go to collab.research.google.com, you should see a list of your most recent notebooks, and you can scroll down and find the one labeled COVID time series. Go ahead and open that. Okay, now it's up to you if you want to make a second notebook and keep the original. I tend to keep my originals, and you can modify this one, or you can always go to File, Save a Copy in Drive. This is what you would do to copy my notebooks anyways. And so, I'll try to provide the link to this one as well. And then you can click Save a Copy in Drive, whether it's your own or mine or anybody else's Colab notebook. And when you do that, you can see that it creates a copy. The advantage here is that now it's yours, and unlike mine, which you can't make changes to, now you can make changes to it. I'm going to call this something different. So it is still going to be COVID time series. I don't know, like maybe it's like better. I don't know, better COVID time series, right? That's the idea. We're trying to make a better one. So what I want to do first is just go down to the output to look at what we wanted to change here. And if I scroll down, we see the data. And then let's look at the first plot. These are counties. We switched to California counties. We're going to transpose and got something like this. The x-axis is totally unreadable. And furthermore, the population is not taken into account. Okay, so those are the two big issues. It's also the case that in this particular graph, this is just too many counties to try to kind of really get a good sense of. You can see it's all of these. And so I chose to limit, to individual counties. You can make your own choices here, which counties you want to look at. And then I just tried to label or graph 3 of those. And so we get a better, physical output. But again, X is unreadable. And furthermore, it's not like necessarily the best comparison because we don't really know what the populations are. So the two things to change are the x-axis, which is just, you can't see it all, and I want to add in the population. When I say add in the population, what I mean is that if you go back to the data, this is the total number of COVID cases per county, right? So if you go to this output, I believe this is Los Angeles County, and so, oh my gosh, it looks like it's so much worse. But is it simply because there are that many more people in Los Angeles County? Well, I searched on Google something like California county's population, and this is a California-demographics.com website. I'm going to go ahead and assume that it is legitimate. I don't know for sure, right? But I think these numbers seem reasonable. You can see Los Angeles County does in fact have the largest population, so you would expect that they would have at least 3 times as many COVID cases as the other populations. Okay. All right. So what you want to do is if you go back to your time series, Colab Notebook, and you find the place where you're choosing the counties. Okay, right here. Here I'm choosing the counties. And next thing I want to do, adding in some new code here, is get population of each county. Now, when you're making this list for the populations, I would recommend that you include anyone that maybe you want to use. Not like you can't go back, but it's nice to do it all kind of in one go. So there are different ways you can do this. I'm not doing web scraping here. All right, so the idea here is simply to make a list using the same order. Okay, you have to be a little careful to do it like this because there is room for error, right? So what I mean is the first, I just realized thought of a better way to do it. We could actually use a dictionary. But look, either way is actually fine. I'm pausing now. Should I switch it to a dictionary? Well, if for those of you who don't know what a dictionary is, let's just make another list. So like here I see Alameda County. I see the population for Alameda County and I put it in there. Now, with Python, you use commas to separate numbers. So you do not want commas and numbers, just use the totals. Okay. And so go ahead and do that now. Find the populations of the counties that you want to look at. Okay. And then what we're going to do is we're going to divide each of the COVID cases by the population to get the rate. And the reason why we are doing that is so that we can rightfully then compare how well different counties are doing. Okay, so I've done this previously, and here are the numbers I have for Contra Costa 1165927. I'm just okay. I'll just write them out. I try to go at the speed that you all might be going at. When you're doing this, I would say right now, just code it. Okay, go in there, go back and forth, get your numbers in. Okay, and just let the video play. And then if I get ahead of you, go ahead and pause it. But I'll keep going. So Marin County has 262321. San Francisco has 873965. And again, all from that list, that other website. Santa Cruz 270861. By the way, to make this process accurate, if I was doing it, Orange 3186989. I would do web scraping because that way, the idea is that you're less likely to make an error because you're going to match the names with the populations in the rows. Okay. I can tell you that web scraping depends on the way the data is stored, can be challenging at times. In Los Angeles, 100,14009. Okay, so this will give me the population of the individual counties that I have chosen right here. And very importantly, they're in the same order. Okay. If you know what you're doing in Python, feel free to make a dictionary and then you can convert the keys and values to lists later. Okay, I'm just going to use two lists. All right, so the other thing is I'm going to go ahead and run the code now. I want to catch up and, I haven't run any code yet. So I can run this code, but if I try to plot stuff, it's not going to work. Because I haven't, let me show you. I could run this. Okay. I'm just defining two lists. Okay. That's totally legitimate. And now, cool. I'm going to try to plot them. I don't know if I haven't made any changes here, but let's just see, does the plot work as expected? No, because PLT is not defined because I have not run the cells above it that this is reliant on. So when you're opening other people's notebooks, you need to be sure you run everything. I'm not going to run everything below, but I'll run everything above. So to do that, you can go to Runtime, Run Before, and now it's going to go from the top of the notebook down in order. And so matplotlib.pyplot will have been imported as PLT. So now if I try to graph it, let us see. It should give a comparable result to last time, and it does, right? So the left side, the Y's, are showing us actually the number of people in the county who have been recorded as having COVID over time, not right now, but over time, the number that have tested positive. But we have the populations now. And so we can divide these numbers by the populations. Okay, so let's look at how to do that first, and then we'll tackle the x-axis. Okay, so this right here is basically, it works more or less like a NumPy array. And what that means is it allows you to do mathematical operations. So if I divide this by this number, which is the number of the population of Alameda, okay, then what that's going to do is divide each entry in the row. Okay. And that's going to give you, not only is that just going to give you us a rate, it's actually going to give the percentage of people who have it. So this is, or who have had it over time. But I don't want to actually do it like that because later, like, it'll be more advantageous to like use the same ordering, right? If Alameda is here, it's the first in the list. So let me use the first element of the list. Let me show you how that would work. Just put in population, counties, and then I can put in a 0 here. That's the 0th member of the list. Contra Costa is second, so I can put that in. I've got San Francisco as 0, 1, 2, 3. Oh, I didn't actually change Contra Costa. So second is the first, because you count with zeros, 0, 1. And now San Francisco is the 0th, 1st, 2nd, okay, 0th, 1st, 2nd, 3rd element of the list. Yes, there's another way to do this. We will do that in a bit. And you know what? Let's give LA a chance here, right? Let's see how they're doing. Because before, it was like, it was just too high up. But now that we're dividing by, you know, this number, it should be a more even playing field. And so it'll also give us a better sense of comparison. Hey, these are urban areas. How is Los Angeles doing compared to, now this is the last. I could do -1 here compared to San Francisco. 1, 2, 0, 1, 2, 3, 4, 5, 6. The reason I'm counting it like that is because we're going to use code to match these later. Okay, and again, label equals Los Angeles. So, you know, these are my choices, you know, for now. You should pick choices that you want, okay? I'm always interested. I could tell you, I live in Contra Costa and work in Alameda, and San Francisco is the, you know, the center of the Bay Area, so it's a place a lot of people like to go. And then LA, you know, nice to compare to Southern California. It doesn't really matter why you're choosing. The point is that this is going to give us should give us a different Y value. So after you go ahead and divide by the number of people per county, and again, what that's going to do is divide each element in this, say, array by that number. And so that is how you get the percentage of the population. Okay, so now let's try it again. And let's look at the difference. It's interesting to like see. Oh, look at that. Wow. Okay, so now these numbers are very meaningful on the left. Okay, what do they tell us? This tells us that 15% of people who reside in Los Angeles County have actually had COVID at some time. That's what this tells us. And it tells us that it looks like it's about 8% for Contra Costa, maybe 7 for Alameda. I don't know. I mean, it's hard to like use it without the grid, which we can get using Seaborn, and possibly 6 for San Francisco. Okay. And the other thing, note that Contra Costa and Alameda flipped. So previously the graph showed Alameda had like a higher number of people who have had COVID. However, Alameda is more populated. Okay. Looks like by about, what are these? Is that like 1 million people? So it's 1.6 million. I just try to like, when I try to count big numbers without commas, I try to comma them, right? So there's like 3. And so they have about 500,000 more people. So you would expect that they would have more. In fact, you know, they're pretty comparable. But you could say, hey, actually Alameda's doing a little better. And, you know, San Francisco impressively, right, is doing even better. Say impressively because it's the most densely populated of the 3. Okay. So it's not the case that it's just like, you know, densely populated areas have a higher rate of COVID. Okay. Although you could also argue that in the Bay Area, these do count as one. They're adjacent to each other, I can tell you, geographically. Well, Contra Costa is further. It's not adjacent to San Francisco. Alameda's between. All right, so let's fix this x-axis. This is just ridiculous. Like, I mean, it looks bad. Okay, so how do we do that? Okay, I can tell you this took some code, and sometimes I'm trying to figure something out. I do it. Sorry, just checking a couple of things. I do it. I go to Stack Overflow and use that. I just look stuff up, and then I keep looking until I find what I need. Okay, so first thing we're gonna do is, so I'm just gonna call this set up x-axis. Okay, we're not gonna worry about the details of the code. Just hey, like this will work. So one thing we can do is we say ax equals plt.gca. GCA is new. I don't even, or it's new to me. I haven't seen it. So just simply put, AX allows you to work with the axes individually. Okay. All right. I need to look up the GCA. So now what we can do is AX dot, and what we can do is we can set the ticks. Okay. They're called tick marks, meaning like these little crowded, like here, you can see the Y ticks are looking not great, right? 0.02, 0.04. But these X ticks we cannot see at all. And so we need to actually set them. So we do the set X ticks. And then how are we going to do that? We are going to do the following code. Okay. Ax dot get X ticks. Okay. And then you can put up in parentheses. And then what this code will do, it's going to choose how we're going to split them. Like how many marks, well, it's actually going to split them. Like by, like if we try like 40, it's going to do one tick mark per 40. Okay, that's the idea. Now, let's just try that and see what it does. Okay, I have some additional adjustments to make. But if my expectation again is that instead of trying to show like every single date here, it's going to show like every 40 days. Okay, you could try like a clean month, would be more like 30. The other thing is we may need some more horizontal, of setting the figure size. It might be a little different when it's for each one. We'll come back to that. Let's just try this. Okay, that did not work the way I thought it would.